Our next speaker is David Autor, the Daniel and Gail Rubenfeld Professor at MIT Department of Economics and co-director of the MBR Labor Studies Program, as well as co-director with John and me of the Stone Center on Inequality Shaping the Future Work. His scholarship, as you probably know, explores labor market impacts of technological change and globalization on job polarization. Over to you, David.
Thank you very much.
25 minutes.
It's delighted to be here. This is joint work with Neil Thompson of the MIT Future Tech and CSAIL, also assisted by Fred Kong, by Christian Vogt on some of the theory aspects of this paper, and other folks who are not here as well. So this paper is about expertise. So you're all familiar with the headlines, of course. AI exposure threatens jobs and wages. And this notion just says, if you're exposed, you're hosed, kind of is the sort of subtext of that. AI exposure is a new buzz term to soften talk about job losses. Here's what it means. But this is not just journalism. This is what economists do all the time. Here are many papers that basically equate exposure with harm. And even one paper by myself with an unnamed co-author who's in the room. And here's the recent paper by Brynjolfsson and Chandra and Chen about sort of, exposure according to the Anthropic Index and negative aspects. But we know that this is too simple, right? Many of us are highly exposed to technology. We don't all think it's displacing us. In many ways, it's augmenting us. It has to be true. Many of the expertise that we possess would be irrelevant without the tools that we use all the time. It wouldn't be meaningful to be an air traffic controller if you didn't have all the exposure to, GPS and radar and two-way radio and so on. So is there good exposure or is all exposure bad exposure? So in canonical task models, of which I'm a contributor, automation is kind of first order bad and second order okay. So by first order bad, I mean automation just means taking a task that was done by labor and now it's done by capital instead. First order, this reduces labor's demand, reduces labor's share of national income. Second order, it might raise wages through Q complementarity, unless it's so-so. So the kind of saving grace for labor in these models is new task creation, which is literally the opposite of automation, right? It's displacing capital and creating new tasks. So I want to add something to this idea, which is the notion of occupations, which are bundles of tasks that are performed together. But these are not all the same tasks. They differ in their expertise levels, and I'm going to define what I mean by expertise in a minute. So that means the same task may be performed in many occupations. When a task is automated, it's eliminated from all those occupations simultaneously. But the impact for occupations is going to differ depending on where the task falls in each occupation's distribution of expertise. And so I'm not going to have time to go into the model, but let me illustrate exactly what I mean. So consider an occupation, and it has 9 tasks in it. And they're ordered from least to most expert. And let's imagine the 3 most expert tasks are automated away. So what happens to labor productivity, to expertise demands, to employment, to wages? Well, labor productivity is obviously going to rise, right? You've made some of the tasks better, cheaper, faster. Average expertise requirements may fall, right? You've knocked out the most expert work. Employment could easily rise, right? Because look, it's now more productive and more people can do it. The expertise barrier has fallen, right? You can have entry. Wages might not rise because although you've made the work more productive, you've allowed many more people to do it, right? So you can think of grocery store cashiers, right? They become much, much more productive over time, right? They check out many more things. They don't handle cash anymore. They scan stuff. So their throughput must be much higher. I don't know how much higher. I've tried to look it up. I haven't found it. But their wages aren't rising despite their rising productivity because it's inexpert work. Anyone can do it. It's always going to be bid down to the minimum wage. Now let's consider another occupation, and it has its 3 least expert tasks eliminated. So what's this going to do? Well, labor productivity is again going to rise. Expertise requirements may rise, right? You've now made this work more specialized. Employment might not rise. You've not made more people qualified for this work. Arguably, you've done the reverse. But certainly wages ought to rise, right? You've enhanced the output. You haven't necessarily increased the supply of labor. So potentially this work becomes more valuable. The expertise that remains is now more useful. It's complemented by what's there. So this is really the basis of the model. And just to kind of give you some examples, these are you shouldn't consider these as evidence. They're obviously cherry picked, but just consider taxi and chauffeur drivers, right? Employment in that occupation grew by 200% between 2000 and 2018, and relative wages of taxi and chauffeur drivers fell. Right now, why did that happen? Of course, we know that's Uber, that's Lyft. That both eliminated a kind of a boundary to entering, so an institutional boundary, but also it reduced the expertise for content required. You no longer needed to know how to navigate to drive a taxi cab. Now think of proofreaders. Proofreaders is an occupation that used to have a lot of mechanical component of spelling, of checking references, of formatting, and now proofreading, or at least until the introduction of AI, was really about helping people improve their writing. Proofreading has fallen considerably in employment over the last couple decades, but relative wages have risen. Arguably, not for sure, that's because this has in some sense become a more specialized, more expert activity. Or just go back one more slide here, take an example. Imagine the person on the right is Jerome, but imagine Jerome uses AI. And the person on the left is Jerome's assistant. And Jerome, writes a million things a day. And a big constraint on Jerome's work is he has to wait for a team of expert proofreaders at the end of each day to read his work and help him error check it. But now, someone gives it Claude to Jerome, doesn't tell him, so he will use it because he doesn't think it's AI. And and all of a sudden, Jerome's throughput goes up enormously. He can now do this on nights. He can do this on weekends. He already does on nights and weekends, but he finds an additional night and a weekend each week. And his output rises, right? So there's a force multiplier for Jerome. But Jerome's fleet of assistants, all of a sudden the most expert work in their occupation has been eliminated, right? So the same act of automation is a force multiplier for Jerome and eliminating, decontenting the work of others. So that's, this paper is related to this literature. Okay, so this is limited time here. Something's got to give. So the formal ideas that go into this model are simply the tasks comprising an occupation are indivisible. They all must be performed. They're there for a reason, right? Some are more expert than others, but like everyone who travels needs to file their travel receipts, even though that's not your job, right? Accomplishing a task requires task-specific expertise, specific know-how or judgment. It doesn't just mean education, right? This can, this could be like, coding an app or baking a loaf of bread or, remodeling a kitchen, right? But we are going to assume that expertise is hierarchical for the purposes of this paper. Obviously, there could be many hierarchies. For this paper, we're going to think of it's hierarchical. You think of it like stacking dolls. More expert workers can do what less expert workers can do, but not necessarily vice versa, right? So air traffic controllers and crossing guards, basically the same job, right? Preventing collisions between vehicles and people and so on. But it's easy for air traffic controllers to be crossing guards, but not vice versa, right? So that's what we mean by hierarchical expertise. Automation will displace labor in some expert tasks, of course, but all occupations will also contain generic, non-automatable tasks. So when occupations are automated, when the expert work is automated, the occupation doesn't go away in this model. It just becomes generic, meaning anybody could do it. So here's a kind of a quick visualization of the model. So we have occupations that are ordered from expertise left to right, and their tasks are ordered vertically. And occupations have a range of generic tasks and a range of expert tasks. And then the red thing is things that have been automated. So once an expert task is automated, right, anyone can do that work. So consider two occupations, phi prime and phi double prime. Both of them, so the one on the right, phi double prime is more expert. It has more expert tasks. Its most expert task is more expert than in phi prime. Both of them have some generic tasks. And then automation is at this I0 level. So they both have some expert tasks remaining. Now, automation advances. In this model, it'll advance from least expert to most expert tasks. That's a parameterization. Doesn't have to be that way. And now look what's happened. This task, phi prime, is now all its expert work is fully automated, right? So anyone could now do this work. It's more productive, but there's going to be an influx of labor. Meanwhile, phi double prime, the least expert tasks have been automated, right? But the most expert tasks remain. So it's more productive, and on the assumption that the expertise distribution is at least initially fixed, that means the scarcity value of the expertise used in this phi double prime is now higher, right? Okay, so now what we do is we find the skip model button, There we go. All right. So here are the primary ideas that we're going to take to the data, and I hope they're intuitive enough that that explanation suffices. So first of all, expert work commands higher wages than generic work, even within education groups, even within occupations. Now that may sound like a content-free statement, so it depends on my ability to convince you that I can measure expertise. The second thing is that changes in the task in an occupation may raise or lower expertise demands. If you eliminate inexpert tasks, you make the occupation more expert. If you add inexpert tasks, you make the occupation less expert, and conversely for removing tasks, right? So adding or removing tasks could raise expertise, lower expertise, or have no effect on expertise, depending on where you took it out. Changes in occupations' expertise demands will have countervailing effects on wages and unemployment, right? Something that makes an occupation more expert will raise its wage, but potentially not increase entry. Something that makes an occupation more generic, right, will potentially lower its wage, but increase entry. So Uber, I think, is a very good example of this, right? The people who are doing Uber, they went into arbitrage and opportunity. Although they lowered the wages in that occupation, presumably it's better than the thing they would have been doing. They weren't mostly taxi drivers, right? So, okay. So what matters is not exclusively the quantity of tasks added or removed, but also the expertise of the tasks that are added or removed. Okay, so now let me give you a roadmap for the next 14 minutes. So first I need to have two measurement tasks. I need to make a measure of expertise that is content agnostic, that's not based on my value judgments. Then I need to measure changes in occupational expertise. And then I want to relate that to four things. First of all, do changes in expertise predict changes in wages? Do they predict changes in employment with the opposite sign? Are changes in expertise distinct from changes in quantities of tasks, right? Are these just the same thing? And finally, these are correlations. And the final part I want to sort of move in a kind of quasi-experimental direction by looking at the removal of routine tasks, the predicted removal, and say that can be variation in changes in expertise and changes in the quantity of tasks and occupations, a function of what was at risk at the start of the period. Okay, so content agnostic index of task expertise requirements. So to do this, we're going to draw on the efficient coding hypothesis. This is an idea that starts in neurobiology, but now it's all over machine learning, data science, and linguistics. And in linguistics, what it means is that natural language speakers face a trade-off between brevity and clarity when they're communicating, right? Brevity is minimizing the amount of words or the number of syllables. Clarity is minimizing the risk of miscommunication. So familiar words like profit and inflation, right? These are sophisticated ideas, but we can throw them around. Everybody knows them. If I say profit, I say inflation, everyone knows what I mean, right? Even though inflation is like, change in the price level, what we know that's not reflected by changes in real earnings power. Familiar words. Expert words like elasticity and arbitrage, right? These are not more sophisticated than inflation and profit, but they're used by domain experts and not encountered by many others. So if I met someone on an airplane and I wanted to explain elasticity, I would say, percent change in X, percent change in Y, and they'd say like, listen, I just want to watch my movie, could you leave me alone? So this leads to a trade-off when you choose words, and it's not just what you know, but what you think your audience knows affects the choice of words you use. So the efficient coding hypothesis explains why experts use distinct vocabularies, not just for pretension, although certainly for that, but jargon has a meaning. Experts develop precise words for events that are common to them, but are uncommon outside of their domain. Right? Elasticity, arbitrage, hyperparameter, right? A word we've all come to love recently, right? Do I hear for hyperparameter? Okay, great. So that says, well, we could use this idea to measure the expertise of job tasks by leveraging this idea. If we had descriptions of tasks, non-expert tasks will use words and concepts that are familiar to most adults. Expert tasks will use words that are infrequent and have low entropy, meaning that if you hear the word, you can predict where it came from. So if someone uses the word elasticity, you could say, probably an economist. If they use the word pernicious, right, you could say, well, they're well-educated. They may be pretentious, but they could be a lawyer. They could be a journalist. They could be an author, right? You wouldn't know where it was coming from. If we had good descriptions of tasks, we could look for their expertise levels by looking at the commonality the commonality and the entropy of the task descriptive word. So that's what we're going to do. We're going to use a book that you all know and love, the Educator Word Frequency Guide from 1995. Everyone has a copy. And it's a compilation of frequency statistics for 160,000 English language words, and it gives a measure of frequency and entropy for each of them. So not only how common it is in these corpora, but how many corpora it's found in. It's pretty cool. So we'll just use this, and we'll transform it in various ways. So lower numbers are less expert, higher numbers are more expert. We're going to use task descriptions for the 1977 Dictionary of Occupational Titles and the 2018 ONET, very different corpora themselves. And we're going to use harmonized employment and earnings data from 1980 and 2018 from my work with Caroline Chin, Anna Solomons, and Brian Sigmore. Okay, so let me show you some high expertise job tasks. Reinstalling plumbing and electrical rigging. May operate punch card tabulating machines such as sorters and collators. Or here's one I really like, sing a cappella or with musical accompaniment, right? Those are not fancy words. Well, sorry, those are simple words, but a cappella is an incredibly low entropy word, right? If you hear it, you know it's from a specific profession. Here are some low expertise job tasks. Print and make copies of work. Transport mail from one workstation to another. Guard street crossings during hours when children are going to or coming from school. I really like that one, right? It's a crossing guard. There's no shortage of words or even multisyllabic words there, right? They're just really common words. Okay, so we're going to do, this is just a validation exercise, right? So I want to show you the relationship between our measure of expertise and log wages at the occupational level in 1980 and 2018. So even without reading my tiny little numbers here, you can see that's a well-determined relationship. Now you might say, look, well, isn't that just education? Isn't that just occupation? Is this really picking up anything else that we don't already know? So here's the same relationship conditional on detailed measures of education. I can also put an occupation. It remains a well-determined relationship. Of course, some of that variation gets soaked up. Of course, that slope is somewhat shallower. This is even true within detailed occupation. So here's all 12 broad occupations that we use. And in 9 of 12 of them, these are positive and statistically significant. The only one that's actually negative is managers and executives. Turns out the more pretentious words they use, the less they know, the more they're paid, I think is a simple way to say this. And just to give you some idea, what does this look like, right? So, for example, if we look at people in service occupations, janitors are much less expert than landscaping supervisors in our data, in our measure, and they make significantly lower wages. Or if we look at clerical workers, let's say technicians, chemical technicians appear to be more expert than machine programmers, also make higher wages. So this is the type of contrast this is making. Okay, so now that's how we measure expertise cross-sectionally, but now we want changes in expertise. And so the problem is that these two corpora, the DOT and the ONET, were written 40 years apart by different people for slightly different audiences. And so there's no way to directly compare what tasks have been added and what tasks have been removed. So what we do is we take each of these tasks, we turn it into an embedding, and we compare them. And so just imagine this in two-dimensional space. So the red are tasks that we find in 1977, the blue are tasks that we find in 2018, and the purple are basically the red and blue next to one another. So if we find a task in 1977, but there's nothing near it in 2018, we say it's been removed. If we find a task in 2018 and there's nothing near it in 1977, we say it's been added. If we find something close to it in embedding space, we say it's been retained. Right? And we're just going to use the variation coming from addition and from removal. So just to give you a sense of what this looks like, here's an occupation, file clerks, from 77-2018. Some tasks that are preserved, for example, are place material in file cabinet, drawers, boxes, or in special filing cases. Here's another one, place materials into storage receptacles such as cabinets, boxes, bins, or sorts. So we get that right. Now here's a task that appears to be gone, may operate key punch to enter data. And here's a task that appears to have been added, input data such as file numbers, new or updated information, or document information codes, right? So this does remarkably well, actually, and really Jean Yeseldir deserves a lot of credit for helping develop this idea. Here's an example of an occupation that's become more expert, proofreaders. Well, what's the main thing that's happened here is it's lost a low expertise task, place, proof, and copy side by side on reading board. And so the mean of our expertise measure rises for that occupation over this time. So that's the source of variation we're going to use. Okay, so we measure this, right? The change in expertise due to things being removed, that could be positive or negative, to things being added, that could be positive or negative, and net of those. Now, of course, you can't have changes in expertise without changes in tasks. So we're also going to look at the change in the quantity of tasks. Tasks added, tasks removed. 50 minutes? 5 minutes, okay, right. All right, great. So the first piece of evidence, do changes in expertise predict changes in wages? So these are the first three things I'm going to show you are just correlations. So the answer is yes. So surprisingly, occupations that appear to become more expert, right, appear to have rising relative wages, and if they become less expert, less so. And this number, although we've normalized this, there really are negative and positive values to this. Interestingly, you can do this both for expertise change due to task removal or to task addition. You get very parallel estimates, right? So those sources of variation give you similar answers. Okay, so that doesn't necessarily seem surprising. So the next thing we looked at is employment. Do things that become less expert tend to grow? And the answer, surprisingly, is yes, actually. So things that become more expert, according to our estimation, see relative increase in wages and relative declines in employment. If you do this using removal and addition, it mostly comes from removal. Things that become less expert because of task removal, they tend to grow. More expert because of task removal, they tend to shrink. We don't get as much variation out of here. Now, of course, you might ask and say, well, okay, but what about, isn't this just a proxy for the quantity of tasks in an occupation, more versus less? And that's, of course, a question we ask ourselves as well. So that's what we want to distinguish in this simple sense. So first, let me just show you. This is the scatter plot of changes in task shares, the fraction percentage change in tasks, and percentage change or change in expertise. And these are basically uncorrelated, right? So occupations that gain tasks don't uniformly become more expert. Occupations that lose tasks do not uniformly become less expert. But nevertheless, let's look at this relationship. So if you look at this for wages, right, the one on the left is expertise, the other one on the right is tasks. We're controlling for both. They both predict higher wages, right? Conditional on expertise, things that get more tasks tend to experience relative wage increases. Conditional on number of tasks, things that become more expert by our measure also tend to rise in wages. But there is a crucial difference. If we look at employment, things that become more expert tend to shrink. Things that get more tasks tend to grow, right? So here's a simple way to think of this. Changes in tasks can be thought of as changes in demand. You get more tasks, right? There's more demand for you, higher wages, higher employment. Expertise is more like a shift in supply. Something becomes more expert, there are fewer people who can do it. You may get less employment. Something becomes less expert, more people enter. You get more employment. So they really are working in different directions, like surprisingly different. Okay, in my remaining couple of minutes, I want to now say, look, those are just a bunch of correlations. Is there anything we can do to make this a little more, get some variation that we can think of as quasi-exogenous? So we're all aware, I hope, by now, this is Geronimo's chapter. I know everyone's read it if they took grad labor because they were required to and tested upon it. We see this occupational polarization, this decline in the 90s of middle skilled work. Many people think of that as reflecting the removal of routine tasks. Surprisingly, there isn't that much wage polarization, not nearly as much as there is occupational polarization. There are lots of interpretations of that having to do with selection. That basically the people who remain in the middle skilled work are the better ones. I think that's quite plausible. Here's another interpretation, which is that changes in expertise bifurcate. Changes in routine task removal bifurcates the expertise per distribution. So let me just say, in our data, we see a big decline in routine tasks, and most of the tasks that are removed are routine. Most of the tasks that are added are abstract. So we had the following idea. Let's just take each occupation, identify the routine tasks, and imagine what happens to expertise and to the quantity of tasks if all those routine tasks are removed. And then we can use that as a predictor of changes in expertise, a predictor of changes in tasks, and then regress wages and employment on that. So just let me show you what this looks like. These are percentiles in the income distribution. These are the potential changes in expertise if all routine tasks are removed. So payroll clerks and accounting clerks are both around the 33rd percentile of income distribution. We predict that payroll clerks, if they lose the routine tasks, they become much less expert. Those are their most specialized work. Accounting clerks, that's their supporting work. They become more expert. So here's what that looks like. So here is, you can think of this as a reduced form. Sorry, it's a first stage, excuse me. This is the change in actual expertise as a function of change in predicted expertise. You could fit this as a single line. These have the same slope. I'm just saying here's on the negative orthant, things losing expertise. Here's things gaining expertise. And these slopes are pretty comparable and pretty well estimated. So this does work in terms of predicting changes in expertise. I have to ask myself a question now because I'm out of time. What is the next slide, Autor? So now we do the same for wages.
He did design the program, okay.
That's right. We do the same for wages, right? And lo and behold, things that become more expert as a result of routine tasks this is the predicted value. Relative wages rise, and here they fall. Again, we're just using the variation in initial routine task exposure. This says it's bifurcating the expertise distribution. If we do this for employment, again using the same prediction, we see things that are predicted to become more expert because they're losing routine tasks tend to shrink. Things that are predicted to become more expert because they're gaining, as they lose routine tasks, tend to grow. Okay, so let me just conclude. Automation, both replaces experts and augments expertise. The relevant question is not exclusively how many tasks, but also which tasks. What is their content? Focusing only on technology exposure, as many, many papers do, sort of assumes replacement, ignores this augmentation component. So, checkout clerks and data scientists, both highly, highly exposed, right? Different implications. Air traffic controllers and crossing guards. First, highly exposed. Second, not much exposed. Who would you rather be, right? So we think that research should consider the quantity and expertise, i.e. the content of job tasks, in addition to their quantity. So the current paper is just predicting the past. Usually pretty easy to do. So we hope in our next endeavor to apply this approach to extend from backcasting to forecasting, to have something more to say about tradition expertise. Thank you very much. And here are the people who helped us.
So we have 7 minutes for Q&A in this instance. Who's got a question?
Very interesting.
People on the drawn are strongly encouraged to ask questions, but go ahead.
I'll ask several since now. So I guess one thing that I'm sure you're worried about, but is whether there is also a selection in the more expert occupation. Because one thing that would generate this pattern is that in your expert occupations, only the more skilled people.
Sure. I mean, a lot of this, so certainly when we have the entry thing, that's exactly what's happening. In our model, it doesn't happen exactly in parallel, but we have checked this. And it is the case that part of it does appear to be changed by change in the composition. I wouldn't object to that at all, but not all of it.
So that sort of links in some sense. So there are two hypotheses here. One is like the weak Autor and Thompson hypotheses would be that expertise matters. Mm-hmm. But that would be consistent with just expertise is just a word for the more skilled people within that occupation. The other one is that expertise is associated via the bundling of tasks somehow with some augmentation or so in some sense, I think the evidence you're showing is very strongly in favor of the weak hypothesis and may or may not be in favor of the strong hypothesis, although I may be missing some parts of it.
No, what I've shown, I don't think you can distinguish that. In the paper, but it's really only a footnote at this point because it turned out to be hard to explain and didn't go anywhere, was we accounted essentially, we predicted wages in each occupation according to composition each period and looked at the change in actual minus predicted to look at the residual, and effectively almost all of it is coming from that. It's not coming from changes in the composition as far as we can tell. Now, there may be better ways to do it, but I think that I think we're comfortable with the strong Autor Thompson hypothesis.
Over here, Christian.
Can you say more about like the boundaries of tasks and occupations over time in your data? So like if I remove a task that's like a low expertise task, can you see if like it gets replaced with a new task that's low expertise or high expertise? Or if you think about, like, if I remove enough tasks, like I make the doctor job easier,
Yeah.
when does it just become part of the nurse's job?
Yeah, good. That's right. So we're not modeling, how occupation boundaries are defined or redefined, right? Which I think, is obviously the right question to ask and the next step on this agenda. These occupations are pretty broad, right? So like doctors are pretty much one category in these data. And I think there's a lot of, if you said like, look, doctors' tasks have changed, very deeply over the last century, but we still recognize them as doctors. So I think that I don't have a perfect answer to that question. And I think we haven't asked, why are these, we haven't modeled why they're bundled together, right? And also you might say, well, maybe it's not just the expertise or even the number, but also the diversity themselves, right? Which is kind of consistent with the paper that Larry Schmidt presented a week and a half ago at the macro seminar. And that's also something we haven't looked into, but I think it's a super good question.
Here, and like Christian, go ahead, you guys.
So you talk about backcasting to forecasting. I was
Yeah.
curious if you could speculate and do a bit of nowcasting. Like if you took the model and mapped it to the conversation about entry-level programmers, entry-level scientists no longer being hired, how would you think about it?
Yeah. So there are two things that are happening simultaneously, right? In the entry level, data center scientists and computer programmers, right? One is arguably like a lot of the supporting tasks are being eliminated. So maybe that works more expert. But then many tasks are being eliminated, right? Which works in the other direction. It's a little early for me to speculate. But I would say if our nowcasting exercise, to the extent we've done it, says like that doesn't look really especially good. Like our model isn't totally surprised by what Brynjolfsson et al. Are finding, for example. But that's a very concentrated result. We don't think we see that in many other places from what we've done so far.
Their result is very concentrated.
Our prediction of where you might see actually, the gain in expertise would be overcome by the loss of task is in a very limited range of activities from what we've seen so far.
Thanks, David, for a really interesting paper. And to build on the one prior question, the sort of choice around automation of any task and which profession it goes into there's a little feedback loop there, I think, and I've often thought sometimes that what's constant is the profession. The doctor is the doctor, and the tasks kind of come and go in order to preserve that doctor's role. And I don't think that's inconsistent with what you're saying at all, actually. But the relationship between those bundles and who gets to decide whether a piece of automation, and I think about an example that you helped me appreciate a long time ago about just clerical work on this campus, right? Is email automating away clerical workers' work, or is it adding tasks to my daily job, and who wins and who loses out of that story? And through many small choices, those things get decided, but a priori you wouldn't be able to look at email and say, this is replacing clerical or augmenting professor.
Yeah, I mean, I think the fights over occupational boundaries are vicious for this reason. And people have very strong feelings about losing expert versus inexpert tasks, right, which they're happy to cede to others, right? So the fights between nurse practitioners and doctors, for example, or like John Horton, our colleague, gives this example. His family runs a construction firm, and if you think about construction workers, right, they're virtually cyborgs, right? They have so much equipment, everything they do. And if you're building a wall, a concrete wall, has rebar, and that's a kind of routine activity. But at the very top of the wall comes these rebar ends, and they have to be tied, and that's a very skilled activity. And so union people have always done this. But now you can go to Home Depot and buy a rebar tying gun for a couple grand, and then any idiot can tie rebar. Well, the unions won't allow this to occur on their sites, right? And it's like, well, why? What, they like jackhammers, right? They like pneumatic nail guns. It's very obvious, right? This is an expert task. You don't want to give it up. So I think people intuitively understand their feelings about the tasks that they do and how valuable they are depends on whether it's like something anyone can do, it's not scarce, or something that only I can do, it is scarce, and I don't want to see that scarcity eliminated.
I think a lot about the medical x-ray, where in the early days it was the doctor who operated this complex machine, and there was all this ritual around the film and the development, and then over time that became assigned to basically a technician, maybe a nurse, and they do it all today, except for the doctor still walks in and gives the diagnosis. When you darn well know that that technician knows where your cavities are by looking at the x-ray, but they're not allowed to have that task. It's still the doctor's.
Unless you're in northern Alaska with the Inuit, then the dental hygienists are allowed to do exactly that task.
Exactly, and there are many places.
Because the dentists don't want to go there.
Okay, thank you very much, David. Round of applause, David. Thanks to everyone for coming, and of course to our speakers for sharing their brilliant work. We will continue this series of micro conferences in the spring semester, probably with a virtual one. And we have an official in-person launch for our Stone Center on November 3rd, and we'd love you all to join us. Literally, all of them. They can come. Well, there you go. That's the invitation right now. Julie gave me 2 thumbs up, so take us up on that. We have a monthly newsletter, which you can sign up at the front, being pointed out to you now. Thanks very much to the Stone Foundation and the Hewlett Foundation for making this event possible. Have a good evening.